and just different kinds of things about triangles. We're going to keep working with triangles. Triangles are one of our friendliest shapes in geometry, triangles and circles. And so we'll start this semester talking about some special things inside triangles. So rather than comparing triangles, we're talking about things that are happening inside triangles. So we're in section 5.1, and we're going to talk about triangle midsegments. So our big idea for today is what we call the triangle midsegment theorem. And the triangle midsegment theorem tells us that the segment that joins the midpoints and before we write the rest, let's remember what we mean when we're talking about a midpoint. What do we mean what's a midpoint? The middle. It's a point in the middle. So the midpoint of two sides of a triangle so we're finding the middle of two sides of a triangle, and we're drawing a segment between them. And we'll draw a picture here in just a second. Is that segment is parallel to the third side of the triangle and half as long. So when we have a mid-segment, we end up with this kind of cool thing happening. So let's draw a picture about what we're talking about. So there's my triangle. And we're going to join the midpoint of that side and that side. So there's my segment. So if this is the midpoint, if this point is the midpoint of this side, what do we know about this segment and that segment? They're equal, their lengths are equal, so we can mark them like so. Those are congruent. And this point is the midpoint of this side, so what do you know about these two segments? Same thing, they're congruent. And we know that this segment is parallel to the third side. So how do we mark that things are parallel? What symbol do we use for parallel? Remember? To show the lines or segments are parallel? The little arrows, yes. So the arrows tell us that those are parallel. And let's give these points some names. We'll call this A, B, C, D, and E. So this is what our picture would look like. These points are the middle of these two sides of the triangle. These two segments are parallel. And so we would say DE is parallel to segment AB. And it says that this segment is half as long. So DE equals 1/2 AB. What's another way that we could say, a different way that we could say that this segment is half as long as this one? How long is segment AB? If this is half as long as this one, how long is segment AB compared to segment DE? DE, not squared, but 2 times. So we could say that AB is 2 times DE. So this segment is twice as long as this segment. So that's the other way we can say it. So these two things tell us the same thing. So we can think of this piece being half the longer piece, or we can think of the longer piece being twice the smaller piece. Either way works. They tell us the same thing. And when we solve problems with them, we can do it. We can set it up either way. And sometimes it depends on which one we know as how we want to set it up. We usually prove the mid-segment theorem using coordinates. So we plot our points on a graph, and we use the midpoint formula, the slope formula, the distance formula to figure all of this stuff out. So I want to remind you of a couple of things. We're not going to go through the proof, but I want to remind you about, or I want us to think about, how are the slopes of parallel lines related? They're the same. Slopes of parallel lines are the same. So I'm just keep that in the back of your head. And it comes up in the homework. To find the midpoint between 2 points. I just wanted to remind us of our midpoint formula. Do you remember how to find our midpoint? X1 plus X2 divided by 2, and Y1 plus Y2 divided by 2. And this is our X and this is our Y. So that's how we find our point. We add the X parts and divide by 2, so we're finding the average, finding the middle, and we add the Y parts and divide by 2. So that's our midpoint point. And one or two of the problems in the homework have to do with finding a midpoint. All right, so that's our big idea for this section. So all I want to do is go through a couple of examples of how we're going to use this mid-segment theorem with triangles. So any questions before we go on? Okay. So let me draw a picture here. We're going to get a triangle inside a triangle. And we'll figure out some parallel So I'm going to call this D, E, F, and M, N, and O. And those two segments are congruent. Those two segments are congruent. And those two segments are congruent. And our questions are, which segments are parallel? So let's figure out what this picture is telling us. So because these two segments are congruent, what does that tell us? Where is point O on this segment? It's the midpoint. Where is point M on this segment? Since these two are congruent. It's the midpoint, it's in the middle. Same thing here. So what kind of segments are these three? Where the ends are between the middle of two sides of the triangle. What's that segment? What was our theorem that we were just talking about? It's going to be the mid-segment. This is the middle of one side, this is the middle of the other side, so this is a mid-segment. This is the middle of this side and the middle of that side, so that's a mid-segment. This is the middle, that's the middle, so this is a mid-segment. So our segments, the smaller triangles, are made up of mid-segments. So all of the sides of the small triangle are mid-segments. So each side of the triangle is a mid-segment. So let's look at side DE. Let me get a highlighter going here. So segment DE is going to be parallel, since this is a we have mid-segments here. What segment is DE going to be parallel to? MN. I'm going to highlight that. DE is going to be parallel to segment MN. How about segment DF? Which segment is that going to be parallel to? ON. And finally, let's do this one in purple. And I'll write over here. Which segment is parallel to segment MO? FE. So because these points are in the middle of each side of the triangle, we know that the smaller segments are parallel to the opposite side on that triangle. Each of these is a mid-segment, so it's parallel to the other side. Questions on that example? All right, let's look at another one. This time we'll talk about, rather than parallel, we'll talk about the lengths. So there's my triangle. And we'll call this S, R, and T. And this is K, G, and H. And we know that G, H, and K are midpoints. So each of these points is right in the middle of this segment. And we know that segment RS is 28. Segment GH is 20, and segment RH is 22. And we want to know how long are segment KH, segment ST, and segment GK. Well, because these points are at the middle of each side of the triangle, what kinds of segments are these? Mid-segments. They're mid-segments. They're at the middle, their endpoints are at the middle of each side of the triangle. So let's start off with this. RS is 28. So let's highlight again. RS is 28. So which mid-segment is going to be related to segment RS? KH. Okay, so that's our first question. So if RS is 28, how long is KH going to be? 14. It's half as long. Because these are midpoints, this segment is half as long as that segment. So let's look at GH now. We'll highlight that one. Here's GH. Can you see that? Not really. Red. There we go. So which segment is GH going to be related to? Which one is it? ST. And if GH is 20, how long does ST have to be? What was it? Is GH smaller or bigger? Smaller. So if it's 20, how long does ST have to be? 10? 40. It has to be longer. It's twice as long. This side is twice as long. So that would have to be 40. So if this is 40, this side is half as long, this side is 20. So this length has to be longer. It's bigger. And let's look at last one, RH is 22. Well, which segment is segment RH related to? GK. And if RH is 22, how long is GK going to be? Has to be 22 also. Because this is half as long as this whole side. This is half as long as the whole side, and this is also half as long as the side. So GK has to be 22. So mid-segments are parallel to the third side of the triangle, and the mid-segment is half as long as the third side of the triangle. Questions on those two examples? All right, one last example. So in math, we always like to add, instead of just numbers, we put variables in there. We put an X in our problem. So let's do a problem where we have an X in it. So we're going to say these two are congruent. Those two are congruent. So before we even go any further in this problem, what do we know about this segment? What kind of segment is it? It's the mid segment. It's in the middle. The endpoints are in the middle of each of these sides. So we're going to say this side is 38. And that side is x plus 2. And our problem asks us to find x. So how are we going to go about finding x here? Perfect. We know that the mid segment is half as long as this side. Well, half of that side, 38, divide it in half, that equals x plus 2. So 38 divided by 2 is what? What is it? 19. Subtract 2 from both sides. X equals 17. Is there another way we could have set this up? We could have said, or x plus 2, and here we have to be careful, parentheses, times 2 equals 38. And then I could distribute 2x plus 4 equals 38. Subtract 4. 2x equals 14. Divide by 2. And x equals 17. I could do it either way. They tell me the same thing. If I multiply this segment times 2, the length of that segment times 2, I get that segment. That's what we're doing here. Or if I divide this one by 2, I get this one, and that's the way we did it here. So we get the same thing either way. Yeah.
14 divided by 2 is 7.
This shouldn't be 14. This should be 34. 38 minus 4 is 34. If it were 14, then we'd have a problem. We'd be inventing some kind of new math. All right, so all the homework today is in finding parallel segments and talking about lengths of mid-segments of triangles. That's really all we're doing today. Pretty quick, pretty easy, quick, easy day. All right, there you go. Once everybody has this, I will put the book page up on the screen.